Robot kinematics include forward kinematics and inverse kinematics. Forward kinematics calculates the pose data of the robot from the joints. Inverse kinematics uses robot pose data to determine variables for all the joints. Generally, the result of forward kinematics is unique and easy to obtain, but inverse kinematics might develop multiple solutions and require more complicated analysis. The forward kinematics command in Elite Robot is joint to pose. Joint number 1. This is joint position using variable p. The range is 0 to 255. It is the joint coordinate variable to be converted from. The p variable stores the angle data of all 6 robot joints, using J1 to J6 to define each joint axis. Pose number 1. This is Cartesian using variable v, ranging from 0 to 255. This stores the Cartesian coordinates calculated by forward kinematics. The v variable stores the Cartesian coordinates in reference to the robot base. The coordinate data is usually defined by x, y, z, rx, ry, and rz. For example, insert the joint to pose instruction. After execution, the value of P000's joint coordinates are converted into Cartesian coordinates and stored in the V000 variable. The inverse kinematics command in JVI programming is pose to joint. Pose number 1. This is Cartesian using variable v, with the range of 0 to 255. These are Cartesian coordinates to be converted from. Joint number 1. This is joint position using variable p. The range is 0 to 255. This is the variable to save the joint coordinates after being calculated by the inverse kinematics. Please note, since the joint axis status is not specified, the calculation result using inverse kinematics command might be a position at a singularity point, which will cause a fault alarm. Therefore, using the Lewis script for the inverse kinematics is recommended. Program example. At line 7, after the program is executed, the result of converting data from P001 is assigned to V001. The pose multiplication command posemul. Pose number 1 is used as the origin. Pose number 2 is used as the offset pose matrix. After the offset calculation completed, the data stored in pose number 1 will be replaced with the result. Please consider the RPY of pose number 1 when using this command for offsetting purposes. Since MoveL supports v-variable operations, the position can be adjusted by offsetting an element with the v-variable. An example of the v-variable's element offset, since v0, x, y, z, rx, ry, rz, the index of the array starts from 0. So v000 parentheses 0 parenthesis represents the first element in the variable v0, which is the x direction. v000 parentheses 2 parentheses represents the third element in the variable v0, which is the z direction. Add is just an addition operation. Therefore, add v000 parentheses 0 parentheses 60 means to move the v variable forward 60 millimeters in the positive direction of x in the base coordinate system. In the program, insert a move L command. Use v000 for the v variable, then insert add command. Select v variable, change index to 2, and set constant value to 50, which means modifying z-axis by 50 millimeters in the positive direction. Insert another add command and add 50 millimeters to x-axis of v000. At last, insert move L command after each add command. To make the result move more obvious for viewing, add a 0.5 second timer to the program. Run the program in play mode. The robot moved up 50 millimeters from the original position. After a short stop, the robot moved 50 millimeters in the positive X direction.